Welcome back to the Best Writing on Mathematics channel. I offer in this video a brief outline of the contributions to the 2016 edition, with a caveat that the sophisticated arguments made by our authors and the assumptions that support those arguments are worth reading in detail, comparing, corroborating, and contrasting. Hyman Bass reveals the learning experiences that shaped his views of mathematics and places them in a broader discussion of the complex rapport between mathematics and its pedagogy. Daniel Silver presents H.G. Hardy's blazing ideas from that most famous exposition of a working pure mathematician, A Mathematician's Apology, and gives us a potpourri of reactions that followed its publication. In a piece that can be seen as a genuine continuation of the same theme, Hannah Elizabeth Christenson and Stephan Ramon Garcia detail the fortuitous confluence of mathematics, cricket, and genetics, all of which conspire to make Hardy, at least for once, an applied mathematician. Derek Abbott contends that the applicability of mathematics is considerably overrated, takes the decidedly anti-Platonist position that mathematics is entirely a human construct, and proposes that accepting these unpopular tenets will accelerate progress, as he tells us. Aided by suggestive and clear illustrations, Burkard Polster manages to use no formulas in a plain language proof of a geometric result concerning circles arranged in a rectangle, and leaves us with a few challenges on the similar topics. Joshua Bowman considers the problem of periodic path of billiard balls in pools of triangular shape. He gives some known results and mentions a few open problems. In his second piece included in this volume, Burkard Polster teaches us how to invent our own variants of the card game Spotted. Jennifer Quinn reports on a contest in mathematical virtuosity with participants so ingenious that the victor cannot be settled on the spot. All this comes from one of the newly popular, enormous, always sold-out arenas of mathematical gladiatorial disputes. In a compelling piece that combines elements of group, string, and number theories, Erika Klareich waves together considerations made by several mathematicians and physicists struck by the connections they find among fields of research apparently far apart. Davide Castelvecchi describes the avatars of the proposed proof for the ABC conjecture in number theory, and relates them to the peculiarities of the proof's author, Shinichi Mochizuki. Kevin Hartnett tells the decisive story of a recent breakthrough, Ciprian Manolescu's proof that some spaces of dimension higher than 3 cannot be subdivided. Stephen Strogatz presents a brilliantly insightful proof of the Pythagorean theorem from the young Albert Einstein. In a semi-autobiographical recollection, Brian Greene outlines the evolving speculative assumptions of the physicists who developed the mathematical underpinnings of string theory. Tanya Kovanova, Eric Nee, and Alok Puranik describes step by step a generalization about hexagonal grids of a fractal iteration first proposed by Stanislav Ulam. Mark Franz shows us beautiful fractal images and explains how he constructed them. Joseph Dauben and Marjorie Senechal took strolls through the Metropolitan Museum of Art in New York and discovered a treasure trove of mathematical content, some in plain view, some deftly hidden in details. Alan Schoenfeld places the contentious Common Core standards for school mathematics in perspective, relating them to previous programmatic documents in the United States education and discussing their rapport with a few important issues in mathematical instruction. Catherine Bills and Barry Garlick take a decidedly critical stand toward the same Common Core, arguing that the standards run against the developmental constraints and may in fact impede the learning of mathematics, not promote it. David Acheson, Peter Turner, Gilbert Strang, and Rachel Levy present 4 visions of teaching applied mathematics, each of them emphasizing different elements they see as important in such work. David Rickeson details the very early history of one of the most widely recognized mathematical facts, the constancy of the proportion between the circumference and the diameter of the circle. Isabel Serrano and Bogdan Suceava reconsider the contribution of the medieval thinker Nicolas Orismy to the history of the idea of curvature and conclude that Orismy deserves more credit than he is usually given in accounts of the history of geometrical concepts. In a similar reconsideration, but with an opposite twist than Serrano and Suceava, Victor Blasio contends that Gottfried Wilhelm Leibniz receives too much credit for so-called proving the fundamental theorem of calculus. Amy Shell Gelash examines some connections between geometric curves and mechanical drawing devices, with a focus on the drawing toy spirograph. John Stilwell ponders what qualities might account for the depth of mathematical results and compares from this viewpoint a number of well-known theorems. Drawing on their work experience, Marco Putz, Pete Doss, and Ton DeVal propose solutions for the instances in which errors find their way into large sets of data. Brian Hayes summarizes the problematic current state of achievement in the quest to construct probabilistic as opposed to deterministic programming languages. In a piece that combines psychological insight and mathematical rigor, George Almeida analyzes several common misperceptions of the people who attempt to rationalize the most likely outcome of the lottery process. Andrew Gellman explains why some research claims based on the null hypothesis significance tests are spurious, especially in psychological studies. Howard Weiner and Richard Feinberg point out that the practice of administering long tests under the uncritical pretense that they result in accurate assessments leads to colossal waste of time when aggregated to a social scale. In the last piece of the volume, Jan Stewart attempts to circumscribe popular writings in mathematics as a genre, affirms its value for the public, and advises those who want to contribute to it. Besides these pieces, the volume The Best Writing on Mathematics 2016, as usual, includes a long list of osorans, a long list of notable writings, including hundreds of other titles. Thank you for listening to our video.